webinar. Today we'll be talking about this, which is what is RSK and what is Nifty Wallet. I'm Brendan. I'm a developer advocate at RSK, and I'm from Singapore. I used to be a JavaScript developer for the most part. I've run a technical meetup called dApps Dev Club here in Singapore, and I'm currently learning Spanish as well. Okay, so here's what we're going to learn today. So we'll learn about RSK, and then we'll also learn about the difference between custodial and non-custodial wallets. And as part of that, we'll learn about keys as well. And we'll also look at Nifty Wallet, and we'll use that in a bit of a hands-on way to connect to the RSK network. And finally, we'll send some RBTC to each other on the RSK testnet. Okay, so firstly, what is RSK? It's a blockchain project which is powered by the Bitcoin network. So it has its own blockchain protocol, and it uses that to run a virtual machine that is very similar to the Ethereum virtual machine, but it doesn't. It uses Bitcoin to give it its power, right? So the strength of a blockchain platform is based on how secure it is. And so the likelihood or the possibility or the cost involved in double spending or making a duplicate transaction or something like that, right? So with Bitcoin, you have the largest possible hash rate in the world, and RSK taps into that. And it makes it possible to run smart contracts on top of Bitcoin. And that is, I guess, the central part of RSK's offering. And so by doing that, it adds value to the Bitcoin ecosystem. So you get smart contracts, and then you also get near instant payments from faster block times compared to Bitcoin, as well as the ability to build more complex things, which we'll get to later. For example, the Lumino network. And it is also more highly scalable than Bitcoin. So there are a few pillars that make RSK what it is. So there's merge mining, which means, which I mentioned earlier on. So Bitcoin miners can optionally also choose to validate RSK blocks, and if they do so, they get paid some RBTC, and that RBTC converts directly into Bitcoin. So they get additional value for participating in the RSK network. And this is a win-win because the miners get paid more for effectively the same amount of work, but they in addition to that, what we get in RSK is a more secure smart contract platform. There's also a global federation, which is part of the bridge between RSK and Bitcoin. So we'll get into a bit of the details, more details later on. But essentially, when you use RBTC and BTC, they're exchangeable. And when you transfer value from Bitcoin into RBTC, you have to lock it up somewhere. And the party responsible for doing that is the federation. The other thing is that RSK is fully compatible with Ethereum. As mentioned earlier on, there is a virtual machine that's very similar to the Ethereum virtual machine. The compatibility is almost 100%. So every time there's a new opcode, for example, added to the EVM, the RVM also adds that same opcode. Bitcoin is also used as fuel for smart contracts with the RSK bridge. So what that means is that you can pay for your gas fees using Bitcoin. Yeah. So this is the two-way peg mechanism mentioned earlier on. So on this side, we have Bitcoin. On this side, we have smart Bitcoin, RBTC. And that icon in the center, that is the RSK Federation. What happens is when someone wants to get RBTC, what they do is they transfer Bitcoin into the Federation. The Federation locks up the Bitcoin and then releases RBTC to that same party's account, and that's called a peg-in. And the reverse can happen as well. The RBTC is transferred into the Federation, back into the Federation, and then the Federation sees this, and then it releases the Bitcoin back to the original party's Bitcoin address. And what that results in is, that's called a peg-in. Sorry, yep, that's a peg-in. So if you lock your Bitcoin in the main chain, RBTC is unlocked in the sidechain. If you lock your RBTC in the sidechain, Bitcoin is unlocked in the main chain. And the Federation is the thing that guarantees that this happens. So here are a bunch of statistics comparing Bitcoin to RSK. The main thing that you probably care about is the very first line, which is that a block confirmation time in Bitcoin is 10 minutes. And in RSK, it's much lower, which is 30 seconds at the moment. It is variable depending on the number of miners. And then right at the bottom, we have the current average transaction cost. So in Bitcoin, that's 24 cents, whereas in RSK, it's just a little bit less than half a cent. So in general, RSK is a faster platform than Bitcoin. And the other thing worth mentioning is that Bitcoin does not do smart contracts, whereas RSK enables you to run smart contracts on top of Bitcoin. So here are a bunch of terms that you may have heard. So the first, the two-way peg, which we talked about earlier. This is when we peg in and peg out between RBTC and Bitcoin. We also use the term Turing complete. So this means that our smart contracts are able to, in theory, execute any code possible. There's a computer science term for that called Turing complete. Now, there is a like sort of small asterisk on that. I would say that they're quasi-Turing complete, because if you were to have a truly Turing complete program, execution could run forever. And what happens is we limit the execution by the amount of gas that you've paid, and there's a maximum limit on that, and it's necessary for any blockchain platform. We also consider ourselves the safest smart contract platform because we're secured by Bitcoin. So the hash rate of Bitcoin is what enables RSK to transactions to be safe from double spending attacks and things like that. We also enable instant payments through, firstly, faster block times, as well as the Lumino network. And you'll hear more about the Lumino network in one of our subsequent webinars. We also have smart contracts, as mentioned earlier on. These smart contracts are fully compatible with those that you may have worked with on the Ethereum network. So the Ethereum virtual machine and the RSK virtual machine are completely compatible. And we also have Bitcoin scaling off-chain. So under the hood, the way RSK works is that it has this two-way peg between the Bitcoin blockchain and its own blockchain. And it hooks into the Bitcoin blockchain at a particular interval whenever it can. And this allows us to have a faster, like a higher frequency of blocks than the main chain that is Bitcoin. So one of the ways to think about RSK is to think about it through this quote from Nick Szabo. So he thinks that Bitcoin is layer 1, and that is digital gold, and layer 2 is digital cash. So the analogy is that no one really goes around paying for their day-to-day stuff using blocks of gold. That would be quite impractical, right? You'd have very heavy pockets. So instead what happens is you have notes, paper notes, plastic notes that represent a small fraction of that value, and you use that for your daily transactions. So, so following on from this analogy, so how else can we make the layer 2 for cryptocurrencies more useful? And adding smart contracts, for example, via RSK, can be one of them. So RSK's solution actually goes a little bit further than that, and you can check out this thing called the Stack, which you'll see on the developers portal. I'll share the link with you later on, or if someone wants to paste that in, Sol or Dulce, if you want to paste the link for the dev portal into the chat right now, that'd be great. So yeah, so here we go. So at the bottom, we have level 1, which is Bitcoin, and that is your store of value, and it's also the main chain. So that's where your proof of work and your security comes from. Then on top of that, you have RSK, which provides you with a level 2 blockchain, right? And that level 2 blockchain also has smart contracts. Now, once you have smart contracts enabled, then you enable this entire section over here, right? So you're able to build so many things on top of a smart contract network. And one of the things, one example is something called the RSK Infrastructure Framework, or RIF, right? So this is, the RIF represents a token, and that token is used to pay for each of these services here. For example, if you want to buy a domain that is hosted on RNS, right? You use the RIF token to pay for that. And the RNS itself is driven by, so it's not just the tokens, it's also RNS itself that's built on top of smart contracts that are built on RSK, which in turn are built on top of Bitcoin. So you've got, you know, the level 3 built on top of level 2, built on top of level 1. And we feel that the security which stems from this level 1 branches out all the way and secures all the things up the way on the stack. All right, so how about like, think about it from yourself. As someone who's interacting with a cryptocurrency, what are the benefits to you? What are the benefits to me, right? So one thing is that we can use Solidity and all of the other tools that we use that are currently very popular in the smart contract world in order to build smart contracts in RSK. So we don't have to worry about that. And the reason for that is because it's fully compatible with the Ethereum virtual machine. It's also faster than Bitcoin. The block time is approximately 20 times faster for each block is added to the RSK Bitcoin, RSK blockchain compared to Bitcoin. And there are also lower cost fees. Instead of 24 cents, it's about half a cent. Now these numbers change day to day depending on the number of miners, but in general, it's much, much cheaper. And of course, all of this benefits that you get do not come at any detriment. You're still secured by the Bitcoin network. So next we'll talk about wallets. So one of the most popular wallets that we have available at the moment is MetaMask. Now MetaMask is an in-browser wallet. So it's for example, if you're using Chrome, you install this Chrome extension over here, and then you have a little icon at the top with all your other browser plugins. And when you visit a website that happens to be a DApp, a decentralized application, then MetaMask gets activated and you're able to interact through that website. Now Nifty is also the same, similar concept to MetaMask. In fact, Nifty is a fork of MetaMask. And likewise, it is also a browser plugin, and it contains the ability for you to interact, or it gives you the ability to interact with DApps within your browser. Now, there are a couple of things that are very similar between the two. So MetaMask is and Nifty both give you this thing called a HD wallet, and that stands for hierarchically deterministic wallet. And that's a standard called BIP 39, governed by a standard called BIP 39, and a few others. And what it is you can create a seed phrase that is a certain number of words, and from that you can generate multiple addresses in a hierarchy. And that is that's something that enables you to operate multiple accounts using the same wallet. The other key feature of it is that it's non-custodial. Now this is very important. So if the main thing to know about wallets is that if it's not your keys, it's not your wallet. So let's say you go to an exchange and you open up a cryptocurrency account with them and you store your Bitcoin in them or any other cryptocurrency. If you don't own the keys, which you don't, right? The keys are actually sitting on the server that's owned by the exchange. That's a custodial wallet, right? Nifty and MetaMask and many others, they are actually non-custodial, meaning you have in your own possession your own keys, and that's very important. That's significant because you completely control whatever is in that wallet. Whereas if someone else controls your wallet and has your keys, then that's custodial, and you basically have to trust them to not do. They have full control over what's in your wallet, and you just have to trust them that they will only execute transactions on your wallet when you actually request them to do so. Yeah. So here's the I guess how it all sits together. So the user, right, goes into their browser and then they install one of these wallets, and if the browser is displaying a decentralized app, then it talks to that browser extension via something called Web3.js. That's what this arrow represents. And these wallets say, okay, so you're going to sign a transaction. Let's give you a confirmation. You get a pop-up dialog. Then the next thing that happens is that these wallets say, okay, once a transaction is signed, I'm going to transmit it to the network. So it makes something called RPC, a remote procedure call, to any computer that's connected to the RSK network. And then the RSK network does its thing. It mines a transaction in a block, and that block is secured using Bitcoin. And all of these transactions, they get returned back to the wallet, also via the remote procedure call. And then the browser learns about it through an update in Web3. So that's the flow. It goes and then back. And here's a orientation of the Nifty wallet. So we'll get to do this in a bit of a live demo later on, but essentially these are the parts that we'll be looking for. So this is a pop-up of the Nifty wallet, and here you can see the account name, and you can edit it if you like. So recall earlier on that I said it was a hierarchically deterministic wallet, so you'll get something called a seed phrase. Now, with that seed phrase, you can go and create multiple accounts. So they're just by default account 1, account 2, but you can give them nicknames if you like. All right. Then the second thing is over here. You can bring down a drop-down menu to have expose several options. You can view Block Explorer. You can display a QR code for your address. Copy the address to your clipboard. You can even export your private key. All right, so over here, we have a drop down to switch which network you're connected to. So Nifty Wallet supports multiple blockchains that are compatible with this particular type of smart contract environment. So Ethereum is one other significant one. We've also got RSK and a few others. So you just have to select the drop-down menu, and you can select either RSK or RSK testnet, and you'll be connected. Now, you could do the same thing in MetaMask as well. With MetaMask, you can select a drop-down and select custom RPC. Unfortunately, with MetaMask, it doesn't have values for RSK pre-configured. So you have to enter the configuration values manually. This is your account dropdown, so you can do a bunch of things to do with your account. Won't read them all out. And also finally you have some settings. So yeah, this button here. So you can see what you get to do there. But it'll be better if we just do them in the demo. So what is a smart contract and what is a smart contract network, right? So before we do the hands-on, let's just talk about this for a bit. So let's start off with an address. So you have an address which just appears to you in your wallet as a long hexadecimal string. This is effectively your public username on the network. When someone wants to interact with your address, send it a transaction or send it some units of cryptocurrency, this is the value that they need. And this is what you should publicly display or transmit to people whom you want to interact with you. The next thing is a private key, and this is also a long hexadecimal thing, but data, but you're unlikely to ever see it. You only see it in very rare things, and you definitely shouldn't send it to anyone, because once someone else has your private key, then they are able to do whatever they want with your wallet. So it must be secret. So when you're interacting with a wallet, these two are the main things that they manage. They have a private key and they have an address, right? So the private key is used to sign transactions, and whoever has it is able to completely operate the wallet. So you can't say, oh, this is my wallet, but I'll give you a private key. Once you do that, then it becomes their wallet too, and you don't want that most of the time. Now, the address is derived from the private key. So if you know the private key, you will also be able to figure out the address. It's a simple calculation. Transactions. So this is where you use something called a digital signature algorithm. In the case of RSK as well as Bitcoin, use something called ECDSA, elliptic curve digital signature algorithm. And you use the value that's stored in your private key, and you use that to sign a piece of data which contains transaction data, right? So this is the account I want to send from, this is the account I want to send to, here's the data, and whatever else you want to include. And then at the end of it, you say, okay, so here's the signature. So then what will happen is other people can verify who have your public key, right? They'll look at your public key and say, yes, this person with this public key who owns the private key that corresponds to this public key actually assigned this transaction. So that's how that's one of the key things that the RSK network does. Now, RBTC is the native currency of the RSK network. So any units of transfer between one account and another is denominated in RBTC. And thanks to the Federation with the two-way peg, one RBTC is always equal to one Bitcoin. Then we also have TRBTC, which is testnet RBTC. And it's basically the same thing, except that it has no value because it's a testnet. So you can get free testnet RBTC at any point in time from a Faucet, and we'll actually be doing that later. Next up, we have gas. Gas is the cost associated with a transaction, and it is used to compensate miners. So what that means is when you do a transaction, right? When you sign a transaction and you submit that to the RSK network, that's just, we say RSK network, but that actually means it's a bunch of computers just waiting there to service your request. Now, that doesn't come for free, right? Someone has to pay for the cost of those computers. And those people who do that, those are called the miners. They're actually running RSK clients. And the RSK clients, they are receiving these RPC calls that come from your transactions, and they're verifying that those transactions are actually correct, right? So they're doing things like digital signature verification for simple transactions. And if the transaction contains data, then they also need to store that data. And they also need to verify that data. And if the transactions are interacting with a smart contract, they need to do all of the above. And then they also need to validate and execute the appropriate things within the smart contract, which again involves more computational costs, more network costs, more storage costs. So all of these things need to be paid for, and the way that you pay for them is when you sign a transaction, you include a small amount of gas in it. The gas is denominated in the native currency, which happens to be RBTC, and part of that gas cost goes towards paying the miners for all of this computational effort that they have expended. And that's what motivates, I guess, people to go to the expense of running RSK nodes. Yeah, and next up we have the contract account. So smart contracts have an address, but they don't have a private key. So this is an interesting thing because private keys, addresses are derived from private keys, but when you create a smart contract, it's a sort of a special case. So what happens is that someone who is not a smart contract creates, uses their private key to sign a transaction, and that transaction contains an entire smart contract, and it sends it to a special address called a null address or a zero address. And when that happens, that smart contract is stored on the network, and from then on, that smart contract is able to add transactions to the network on its own. However, those transactions do not have to be signed, right? Because the smart contract is guaranteed to be executed. They're able to, change the state of the network that's particular to that smart contract because they're autonomous in a sense, right? So whatever code is inside the smart contract will always be executed exactly as what the code is. So the point at which the smart contract is deployed is considered to be the point at which that is sort of set, that those instructions are set. So this is an interesting thing. We won't be getting into the in the subsequent demo, but we will definitely be looking at 1 through 6. So we're not gonna open up Remix here, but what we'll do is we'll actually, let's see, how many participants do we have? Okay, so I would like all of you to do a few things. So firstly, let me share this link. All right. Okay. So I see the link has already been shared. Okay, excellent. So just hold on 1 second. Okay. So I've just opened up a brand new instance of Chrome. So I'll be doing everything from scratch. I have nothing currently installed in this whatsoever. So, right, let's see, I've got MetaMask. So today we're doing Nifty Wallet. So the previous webinar, oh, by the way, if you want to check out all of our webinars, here's the place to do it. And also, while I'm at it, I'm going to be adding a link to the Nifty Wallet here, right? And I'll start the screen share again. Okay. So, first thing, we're going to go and paste that link for POA network Nifty Wallet. So then what you want to do is click on Chrome extension, and you'll get to this page, right? Just press the Add to Chrome button, Add Extension. And then you'll see this notification saying, hey, you've got Nifty Wallet now. So when you click on it, you'll see a terms of use. You just have to read that and then press accept. And then you can create a password. So what this password does is it simply encrypts any wallet data on your computer using this password. It is not your crypto, it's not your user account password or anything like that. So now what I'm going to do is I'm going to take these 12 words over here. This is, I guess you could call it your passphrase. And I'm just going to paste it into a text buffer. As you can see, I've done this a few times before, so those are my other passphrases. They're all for testnet stuff, so don't worry. It's you're not going to be able to steal any funds from me or anything like that. So if I were to for example, forget my password in this Nifty Wallet thing over here, then I'll be able to recover my wallet based on these 12 things. If you're interested, what you can do is you can just do just Google Ian Coleman BIP39 and that URL. So this actually if you select 12 and press generate, it's pretty much the same thing. And if you want to read more, this is the BIP39. It's a standards track for Bitcoin that governs this passphrase or mnemonic code. That's more than you want to know at the moment. Okay, so then the next thing we do is we go to Faucet and we get ourselves some RBTC. So this one, right? All right, so say I copied it somewhere safe, right? And then what you get is you get this account and you get this address, right? But at the moment, this is not an RSK address. This is another network called POA. So one of the good things about this is that it has pre-configured values and configurations for a lot of the various networks. And if you just scroll down, you can go to RSK testnet or RSK mainnet. So for now, we're going to do testnet. We click on that, and what that does is it actually changes your address, but what really changes is the checksum. Okay, so now we're going to copy the address and we're going to paste it there. Actually, just out of curiosity, let's do this. So this is the RSK address, and if I were to pick, say, main Ethereum network instead, and then copy that, right? And this is, right, and you can see that the letters and numbers are all the same, but in some cases there is a lowercase or uppercase difference, and that's actually the checksum. That's how the networks check that this is indeed a valid address. So anyway, let's copy the RSK address and paste the RSK address there. And now we have to fill out this thing. Let's see, 7ASZV. So we'll just have to wait for the next block to be mined, and the transaction in which the Faucet smart contract running on RSK testnet is sending RBTCs into my own wallet. And at this point, what I'd like you all to do while we're waiting for that is to click on this, right? Click on Nifty Wallet, press copy, right? You copy your address and you put it here, right? So I'm going to put mine there. If someone else would like to put your address there as well, that would be great. You can just open up this URL, right? pad.riseup.net/p/RSK wallet, and copy the URL there. Yeah, and please paste your address here so that I have someone to send it to. Okay, so while we're waiting, oh, it looks like the network has sent the transaction. So what we're going to do is we're going to open up this link, and it'll open up the RSK Explorer, and here we go. So let's take a look at the elements of the transaction. Oh, I see we have one address. Thank you very much, Dulce. So this address here, the from address, is the RSK testnet faucet. That's the one, the party that was sending, and 2 is my address. Now we can verify that the address is indeed correct, right? So you can see that this matches this. And then we'll see, okay, they've sent us 1/20th of a RBTC. And then we can see a whole bunch of other details. But one thing that's interesting is that the input is 0. So this is the transaction data. So when you interact with a smart contract, you'll actually have some data over here. But because this is a pure transfer of currency, there is no such there's no need for any data. So the faucet didn't choose to send any data. Okay, so now that's done. Now we can actually send some money to each other. So what I'll do is I'm going to go and copy. Who is this one? Who's in green? Oh, that's Sol. Okay, so I'm going to send something to Dulce, and then I'm going to send something to Sol as well. So let's copy Dulce's address. So that's in my clipboard now, right? That's Dulce's address. And I'm going to click on Nifty again. And then I press the button for send, right? And then I paste the recipient address. Let's just verify that it's the same. Yep. And right now I know that I have a balance of 0.05 RBTC. So I'm going to send 0.01, for example. And then, yeah, let's give some transaction data. This will be completely useless. So the transaction data needs to start with 0x, and then it can be any hexadecimal string after that. So I press next. Ooh, insufficient funds. That's interesting.
You have to be in testnet. You are in mainnet.
Oh, sorry, yeah, that's right. Thanks.
That happened to us too, and to everybody else.
Yeah, I did it right the first time, and then I forgot to switch back when I was demonstrating this. I remember now. Okay, so now that I'm actually in the right network, I should be able to do that transaction. So now I have 1/20th of an RBTC. I'll do that again. So I'm going to copy Dulce's address and press send, and 0.01, and here's my data. Cool. So what it does is it does a round trip with the network and finds out some estimates on how much the gas costs and what's the gas price. So right now I'm sending 0.01, but a tiny fraction of an RBTC. So it's like you can see 0.4 zeros followed by 21, right? So that much extra, that's the gas fee. So I'm effectively going to deduct 1/100th of an RBTC from my account, but then I'm also going to be deducting, 2/10,000th, I think, of an RBTC as well. So my account is going to go from 0.05 to 0.039999 something, right? Okay, so then I'm going to press, then you have a few options. So I'm going to press submit. Oh, that's interesting. Let's try a send without any data. Okay, so I'm going to send to Dulce again. Press next. Submit. Okay, so this time it succeeded. Yeah, I think that might be a bug with in Nifty Wallet. We'll go follow up with them. So, so now what Dulce can see in her own wallet. So if she's running Nifty Wallet or any other wallet that's able to access her address, she'll be able to see that she's got this amount. But we can do that as well. So what I just did was copy the transaction address and then I pasted it here. So for those of you who missed it, what I did over here was press copy next to this one, and I put it over here. Now we can see that the status is pending, meaning that this hasn't been mined yet. So at this point, I have transmitted a message to the network saying that, aha, here we go, transaction 0 confirmed. All right, so this has sent us an XDAI block explorer, which is not what we want. Another piece of feedback that we should send to the Nifty Wallet. So what I'm going to do is I'm just going to modify the URL to keep the same transaction. And so this time we see successful. So these are the same transaction, by the way, the same URL, right? So this, I loaded this page up while the transaction was processing. So we can see from and to 0.01 RBTC, and the status was pending, right? And then over here, which was after I got the notification, I see from and to, they're the same, value is the same, but this time it's successful. So when I see this, right, or when Dulce sees this rather, they know that I have already sent them this amount of cryptocurrency, of RBTC, and that this has been secured by the RSK network, which is in turn secured by the Bitcoin network. All right, so then next up, I'll just do the same thing just to illustrate the process one more time. Okay, so I see one more address from Diana, so I'll do that. I'm feeling rather generous today, sending everyone some crypto. Okay, so I'll press send. So this is Diana's address, and then I'll press next. Recipient address checksum is invalid. Okay, so I think I know what's going on there, Diana. So you may not have done this step. So I made the same mistake earlier on, just a few minutes ago. So click on this drop down over here, and you scroll down. Maybe you left it at POA network, or maybe you selected RSK mainnet. Let's use RSK testnet. The addresses will be different for each one. So you select RSK testnet, and then you press this, right? Make sure that you see RSK testnet here, and then paste it here. Okay, so I see you've got a corrected address. Now, just to illustrate, you can see the letter C here is lowercase, and the letter C here is uppercase. Let's find another example, F and F. There we go. Okay, so eyeballing it, it looks like both of these are the same, so I'm just going to do that. Okay, so this is the new one that I'm going to be interacting with. So send, recipient address is that, and then I press next. Okay, so this time I'm going to be doing the same transaction yet again, and then I'm going to be sending it to a different address this time. This time it's going to go to Diana. And so now we have a pending transaction. So what I'm going to do here is I am going to paste that. And we'll see yet again. So right now, if you go to this particular URL, I'm going to paste it into this pad over here. You'll see that that amount of testnet RBTC is pending for you, Diana, right? So if you see the word pending, it means that it's not confirmed. The RSK network, and in turn the Bitcoin network, has not confirmed that this amount of RBTC has been transferred to you, right? And now I just got this notification. So what I'm going to do is I'm just, instead of clicking on that notification, I'm just going to paste the URL again. So the URL hasn't changed, by the way, so you can just go ahead and do this. Now, if you refresh that page or you open it in a new tab, you'll go from pending to successful. At this point, Diana, you know that you have this amount and you're actually free to perform transactions using this amount. So let's say you started off with 0.05 RBTC from the faucet. Now you have 0.06, and if you needed to do a transaction that needed that amount, that more than 0.05, you needed just that little bit more, now you'd be able to perform that. Does anyone want to try sending me some testnet RBTC so that we can see in the webinar how it looks over here? So this is my address, right? I'm just going to paste it here. So someone can send me the address that's send some RBTC to that token using your own Nifty wallet. Just go through the same steps as I did before. So what I'm going to do while I'm waiting is actually copy my address over here. And then I'm just going to use the RSK Explorer and search for my address. So I started off with 0.05 and I have now I have 0.0299 left. So even though I transferred out twice of 0.01, I have slightly less than 0.03, and that difference can be accounted for because of the gas cost. Just checking if anyone has done a transfer. Am I waiting?
I did a transfer. It's in the chat.
I see. Well, I can't really see the chat while I'm in screen share mode. Let me just see if I can figure that out. Excuse me. Okay, it looks like it has come through. So so we can see here now that Dulce has done a transfer, I've got what I had before plus another 0.1 RBTC. Yep. Events, token transfers. Yeah, I don't have any tokens. Okay, so let's see. Okay, so I figured out how to open up the chat. Sorry, still learning. Okay, so I've got the transaction here. So what I'm going to do from Dulce, now I'm going to paste the transaction. There we go. Yep. Okay, so this is Dulce's address, right? And you can compare it to yeah, right? That's her address. And then 2, that's my address. The 2 field, right? And we can see that she sent me 0.001 RBTC, and so that's how I got that additional amount. Okay, excellent. All right, so I think that basically covers it. If you have any questions whatsoever, please feel free to reach out. You can send your, you can subscribe to more webinars at this URL. You can also email us at developers@iovlabs.org, right? And we'll be happy to field your questions. If you have any questions that arose from today's webinar, or anything about RSK in general, that would be great. Just send it to that email address. We also have a developers portal. right? And this is the URL. You'll find a lot of useful content here. Yeah. Okay, so let's just wind up this presentation. Yeah, so we just did a hands-on with Nifty Wallet, and what we did was we transferred money to each other, units of RBTC to each other using the testnet. We got our initial amounts from testnet Faucet, which is a smart contract that sends us some testnet RBTC. Yeah. And in addition to that, before that, we just covered a lot of questions of what is RBTC, what is a wallet, and how does RSK relate to Bitcoin. So I hope that this session, this webinar, has been informative, and that you've learned a lot more about RSK coming into this. Again, if you have any questions, please feel free to reach out to us, and hope to see you at our next webinars. Thank you very much.
Thank you.
All right. See you, everyone. Bye.